Factorization is the inverse operation of products. That is, if we want to put brackets back into a sum. In simple terms, basically, when they say factorize, you're going to find something that has been multiplied. So factorizing then means breaking down the multiplication and putting it back into an addition or a terms that's been added or subtracted together. So the steps that are involved in factorization, the very first thing that you're going to look out for is a common factor. So if you see a common factor, you take it out immediately. And then the second step, if you see a binomial in your expression, a binomial is an expression with two terms. So you're going to look for the difference of two squares or a sum or difference of two cubes. The third step is that if you see a trinomial is in the form of ax squared plus bx plus a c. So that is an expression with three terms, but having the highest order of degree being to the power of 2. So then you factorize. If there are four or more terms, normally it's four terms with grade 10, you're going to group them, but you're not just doing any grouping. You have to group by looking at a certain pattern. And then fifth, don't forget to factorize as far as possible. So for as long as you have a common factor, even after factorizing your cubes, your squares, always when you see a common factor even into something that looks like the final answer, you still have to take it out so that you've simplified or factorized as far as possible. And lastly, remember terms in brackets can be considered as a variable. If you have an expression in a bracket, the whole expression, we can refer to it as a variable. Okay, we're going to start by factorizing what is known as the difference of two squares as well as the difference and sum of two cubes. So what is a square? A square is anything to the power of 2. So here we have a squared minus b squared. So since a is raised to the power of 2 and b is raised to the power of 2 with a subtraction in between, hence we are calling it a difference of two squares. So let's get more examples of what a square could be in terms of numbers. A 4 is a square because a 4 can be represented in 2 squared. Another number that can be a square, that's a 9, because 9 is 3 squared. All right, you get the drill. So if you have a square minus a square, then we call that a difference of two squares. So how do we go about factorizing a difference of two squares? You are going to have two brackets. One bracket will have a negative and the other bracket will have a positive. Then you say, what is the square root of a squared? That is a. So you're going to have a here, and then there will be an a there. And then what is the square root of b squared? That is a b. Then it will be a b here and a b there. Okay, let's have another example. 4x squared minus a 16. So again, difference of two squares. 16 is 4 squared, so that makes it a square. Even 2 is a 2 squared, making it a square. X squared obviously is a square, so this can be, what is the square root of 4? That is 2. That of x squared is an x. And we will have minus the square root of 16, that is a 4. And then we're going to have another bracket that looks exactly the same, but with a plus 2x plus a 4. Just notice that with that one, we would have to take out a common factor further, but we will discuss that more when we do full factorization of longer expressions. All right. And then one last example. What if I have y squared minus ab plus a 2 squared? Is this still a difference of 2 squares? Of course, because the y is raised to 2 and the whole bracket ab plus 2 is raised to 2. So this whole thing is a square. So factorization of that would be y minus ab plus 2 plus a 2. Then we're going to have another bracket, which is y plus ab plus a 2. All right. So how do we go about now the difference of two cubes as well as the sum of two cubes? With the squares, there's only a difference, there isn't a sum. But with cubes, there is both a difference as well as a sum. All right. So a cube is any term that is raised to the power of 3. Okay. So the factorization of this one, we're going to have two brackets still. You will take the a and the b. So it's going to be a minus a b. So these formulas have to be in your head. And then you will have a squared plus ab plus b squared. And what if it's a sum of two cubes? Then the factorization will be a plus a b. Then the bigger bracket will be a squared minus ab plus b squared. These formulas have to be in your head. You have to be able to recognize the difference of two squares, the difference and sum of two cubes from a mile away. Because as soon as you recognize them in a longer expression, the sooner you factorize them, the whole thing gets hugely simplified. All right, so let's just have a simple example of two cubes. We can have a cubed minus an 8. Okay, so this is raised to the power of 3, that makes it a cube. 8 can be 2 to the power of 3, so that makes it a cube. So that means our a value is a, and then our b will be a 2. All right, so if we factorize this, we are going to have a squared, no, sorry, a minus a b. A b in this case is a 2 because we turned 8 into 2 cubed. So this gives us this b. Right. And then there it's a squared. So a squared will be a squared. Then we're going to have a plus a times b. That will be a times a 2. That will be 2a plus b, which is a 2. So 2 squared will be a 4. And what if we have 9x cubed? A better example would be maybe 8x cubed plus a 1. Please notice that 1 can be anything that you want it to be. Okay. If you say 1 squared, it's going to be 1. 1 cubed, it will be 1. 1 to the power of 1,000 is a 1. All right. So since 8, we know that 8 can be represented in 2 cubed so that it can be in a form of a cube. So what we're going to have is 2x to the power of 3. This is the same as 8x cubed. And then plus 1 cubed. Remember, 1 cubed is 1. So we have 2 cubes now. So 2x will be our a, and 1 will be our b. So substituting into our formula. So this is a sum of 2 cubes. So a is 2x. So we're going to have 2x plus our b is 1. And the bigger bracket is going to be a squared. A is 2x. 2x squared will be 4x squared. Then we have a minus a times b. This is 2x times a 1, which is 2x. And lastly, plus our b squared. B is a 1. 1 squared is a 1. Okay, I repeat, this you have to know with your head. You have to know it by heart. It has to become part of your DNA in your mathematics class. You do need to recognize differences of 2 squares, the sum and differences of 2 cubes when you are asked to simplify to solve for x or to factorize. All right, so in the next video, we're going to do factorization of expressions from some exam question papers.